Dear second prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Geometry Unit 5, Lesson 3. The lesson is called Comparing the Lenses of Sides of a Triangle. You will not observe a big difference between this lesson and the last lesson because they have probably the same rule. Let's start the lesson. Last time we was comparing between the angles in this. Okay, now we comparing between the sides. Okay, last time the givens was the sides to compare between the angles. In this lesson, the converse. The given will be the angles to compare between the sides. For example, if we have a triangle and he gave me the length of this side, which is equal 15, as I explained in the last lesson, and the length of this side, which is equal 6. If he gave me the angle opposite to 15, which is 120, and the angle opposite to 6, which is 20. Here we observe that the big side opposite to big angle and the small side opposite to small angle. And I can classify the theorem like this. In a triangle, if two angles are unequal in measures, and the greater angle in measure is opposite to side greater in length, then that opposite to the angle smaller in measure. Okay, that means when we have two angles equal in measure, then the greater angle opposite to greater side with a smaller angle opposite to smaller side, and so on. Okay, if we have the length of the third side 10 and the length of the third angle 40, now if I need to arrange the angles 20, 40, 120, and if I need to arrange the sides 6, 10 and 15, okay, we see that the smallest side opposite to smallest angle, the middle side opposite to the middle angle, the biggest side opposite to the biggest angle, and so on. Then the greatest angle in measure opposite to the longest side in the triangle, and the smallest angle in measure is opposite to the shortest side in the triangle. Okay. Example 1 with us in the opposite figure. AE parallel to BC, measure of angle A equal 70, DAE equal 70, EAC equal 30 as we see. Now we need to prove that AC greater than AB. Okay, first, to prove that AC greater than AB, we need to triangle included the two sides, and we have already only one triangle. Okay, AC opposite to B, AC opposite to angle B, and AB opposite to angle C. So I need angle C and angle B. It's very easy. Here we have alternate angles. Again, here we have alternate angles, as you see. Then angle C equals 30 degrees. And here we have corresponding angles. Then angle B equals 70 degrees corresponding. Okay, now AC opposite to 70 and AB opposite to 30. Then AC greater than AB. Okay, I'm going to write the proof. Since AE parallel to BC, therefore measure of angle C equal to measure of angle EAC equals 30 degrees, and it's called alternate angles. Therefore also measure of angle B equal to measure of angle EAD equals 70 degrees corresponding angles. Okay, in triangle ABC, since measure of angle B greater than measure of angle C, therefore AC greater than AB. The next question. In the opposite figure, triangle ABC as we see, D belongs to CB, E belongs to AC. That means we have two straight angles. Angle angle B equals 110 ABD. Angle DCE equals 120. Prove that AB greater than BC. Okay, AB is opposite to angle C, so I need angle C. Angle C here, because we have here straight angle, then 180 minus 120 equal 60 degrees. Okay, and without finding this one, I can use the exterior angle. 110 minus 50 minus 60 equals 50 degrees. Okay, then AB opposite to 60, okay, and BC opposite to 50, then the big side opposite to the big angle and the small side opposite to the small angle. Therefore AB greater than BC. Let's write the proof. Since E belongs to AC ray, this given, therefore measure of angle ACB equals 180 minus 120 equal 60 degrees. And since angle ABD is an exterior angle, therefore measure of angle A equals 110 minus 60 equal 50 degrees. In triangle ABC, since measure of angle C greater than measure of angle A, therefore AB greater than BC. Next. Okay, in the opposite figure AB equal AC as we see here, isosceles triangle, measure B ABC equals 65, measure ACD equal 20 degrees, A belong to BD, prove that AB greater than AD. Here a problem, AB and AD are not in the same are not in the same triangle. Then I will not use AB. I will use AC because AC is the same as AB. Okay, now I need to compare between AC and AD. We are going to use the smaller triangle. Here AD opposite to angle 20 and AC opposite to angle D. Okay, so to compare between them, I need angle D Okay, now we have here triangle A B C is an isosceles triangle, therefore angle ACB equals 65 degrees. Okay, to find angle D, we are going to subtract 180 minus 65 and 85. It's equal 30 degrees. Okay, in the lower triangle, here we have AC opposite to 30 and AD opposite to 20. Then AC is a big side and AD is a small side, therefore AC greater than AD, and since AB equal to AC, therefore AB greater than AD. Okay, the proof. Since AB equal to AC, therefore measure of angle ACB equal to measure of angle B equal 65 degrees. Okay, in triangle ABC, since the sum equal 180 degrees, therefore measure of angle D equals 180 minus open brackets 65 plus 85. 85 here, I mean angle C, the whole of angle C, which is equal angle D, of course, 30 degrees. In triangle ADC, since measure of angle D, which is 30, greater than measure of angle ACD, therefore AC greater than AD. Since AC equal to AB, therefore I will replace AC with AB, then AB greater than AD. Okay, the next one. Now we have a right angled triangle. In this right angled triangle, of course, this angle equal 90 degrees. For example, if he gave me the measures of the two other angles, for example, if this angle equal 50, and this angle equal 40. Okay, now we found the biggest angle here is the right angle. It's very clear, this one is the biggest angle. Okay, now as we say before, the biggest angle is opposite to the biggest side. Then the biggest side here is what? Is the hypotenuse. Then this is a rule. In the right angle triangle, the hypotenuse is the longest side. Okay, exactly as the same as the obtuse angle triangle. If we have an obtuse angle triangle like this, we see that this angle, for example, okay, equal 110, and this angle 30 and 100 and here 40. Of course, the biggest angle is the obtuse angle. Then the biggest side here is the side opposite to it, which is the side opposite to the obtuse angle. The rule will be like this. In the obtuse angled triangle, the side opposite to the obtuse angle is the longest side in the triangle. Okay, another rule. Now, if we have a straight line and we have a point outside this straight line. Okay, and I need to measure the distance between this point and the straight line. Okay, I will measure more than distance. The first distance, the distance between this point and inclined line like this. For example, the distance here 7 centimeter. Okay, let's measure another distance. If I measure this distance, okay, and I found this distance equal 5. And finally, I will measure this distance, which is the perpendicular distance, and it is 3 centimeters. Now, which one is the smallest? Okay, it's clear that the smallest one is the perpendicular distance. Again, the perpendicular distance is the smallest distance between point and a straight line. Why? Because here in this area, okay, we can find a right angle triangle like this. In this right angle triangle, the distance or the perpendicular distance is a side, and the inclined distance is hypotenuse, and of course the side smaller than the hypotenuse. And in the other area we have here a right angle triangle like this. The distance or the perpendicular distance is side, and the inclined one is a hypotenuse. Then the perpendicular distance is smaller than the hypotenuse like this, as we said in the last rule. Finally, we can say that the perpendicular distance is the shortest or the smallest distance from point to a straight line like this. The length of the perpendicular line segment, this one, from a point outside a straight line to this line, is shorter than any line segment drawn from this point to the given straight line. And I explained this one in the previous examples. Okay, now what can we do to measure the distance from point to a straight line? Of course, we are going to measure the perpendicular distance. So we can classify this rule. Okay, the distance between any point and a given straight line is the length of the perpendicular, as I said, line segment drawn from a point to the given line. Finally, okay, the shortest distance is the perpendicular distance, and if we need to measure the distance from point to straight line, we are going to measure the perpendicular distance. Okay, the next one. Here we have in the example 4. In this example, AB intersects CD at M. It's clear here. AC perpendicular to CD, that means angle C is right. BD perpendicular to CD, that means angle D is right. Prove that AB greater than CD. Okay, it's already divided into right angled triangle. Okay, in this triangle, AM is the hypotenuse. The hypotenuse, as we said before, is the biggest side. Then AM greater than MC. In this triangle, MB is the hypotenuse. Then MB greater than DM. Then AB, okay, equal big plus big, and CD equals small plus small. Then AB greater than DC. Okay, to prove this one, since first in triangle AMC, since AM is the hypotenuse or we can say that since angle C is right, or we can say that AC perpendicular to CD. Okay, therefore is AM is greater than C. This is number 1. In triangle DMB, since MB is the hypotenuse, therefore MB greater than MD. This is number 2. By adding one and 2, therefore AB greater than CD. The next example. In the opposite figure, ABC is an obtuse angle triangle. Okay, at B here is an obtuse angle. Prove that AE greater than AD. Okay, I will start with the biggest triangle. Here we have angle B is an obtuse angle. That means angle B is the biggest angle, or angle B, then angle B greater than angle C. Angle B equal to angle D, corresponding angles. Angle C equal to angle E, corresponding angles. Then angle D greater than angle E. Then AE, which is opposite to the big angle, greater than AD, which is opposite to the smaller angle. Okay, the proof. In triangle ABC, since angle B is an obtuse angle, therefore measure of angle B bigger than measure of angle C, therefore this is number 1. Okay, and here since ED parallel to BC, therefore measure of angle ADE equal to measure of angle B, and this is called corresponding angles. Okay, therefore also measure of angle AED equal to measure of angle C, and this called corresponding angles. Okay, from 1, therefore measure of angle ADE greater than measure of angle AED. Okay, in triangle ADE, since angle D, our measure of angle D, greater than measure of angle E, therefore AE greater than AD. The next one. In the opposite figure, as we see here, ABC is a triangle, D belong to BC, BD equal to AD. Prove that BC greater than AC. Okay, it's very Easy. Here we have isosceles triangle, therefore angle B equal to angle A. Okay, then by comparing between angle B and angle BAC, angle BAC formed from this part plus this part, then angle A greater than angle B, again angle BAC greater than angle B. Now BC in the larger triangle, BC opposite to angle A or to the big angle, and AC opposite to angle B or the smaller angle, then BC greater than AC. Okay, first, since AD equal to BD, therefore measure of angle B equal to measure of angle BAD. BAD. Okay, therefore measure of angle B smaller than, if I add angle DAC to BAD, then angle B smaller than angle A, smaller than angle, measure of angle BAD plus measure of angle CAD. Those two angles represent angle BAC, therefore measure of angle B smaller than measure of angle BAC in triangle ABC. Since measure of angle B smaller than measure of angle BAC, therefore AC smaller than BC or BC greater than AC. It's the same concept. Example 8. Example 8. ABC is a triangle in which angle A equal 40, angle B equal 75. Order the lengths of sides of triangle descendingly. First, I need to find measure of angle C. Measure of angle C equals 180 minus open brackets 40 plus 75 equal, this is 100 and it's 65 degrees. Okay, now I'm going to draw the triangle like this. A, B, C. Angle A equals 40. Angle B equals 75. Angle C equals 65. The smallest angle opposite to the smallest side. This is number 1. The middle angle opposite to the middle side is number 2. The biggest angle opposite to the biggest side. This is number 3. Then, therefore, measure of angle A smaller than measure of angle C smaller than measure of angle B. Therefore, AC bigger than AB bigger than BC. Example 9. Number 1. If two angles in a triangle are unequal in measure, then the greater angle in measure opposite to greater side in length, and the two lengths of two sides on a triangle are unequal, then the greater side in length opposite to angle which is greater in measure. Number 2, the smallest angle in a triangle opposite to smallest side, of course in measure, in length. Number 3, the longest side in the right angle triangle is the hypotenuse. The shortest distance between a given point and a given straight line is the perpendicular distance. Number 5, ABC triangle measure of angle C equals 110. Then the longest side is, of course, by drawing this one like this, angle C 110, and here A and B, then the longest side is A, B. Number 6, ABC triangle angle A equal 50, B equal 30. Then the shortest side, I'm going to draw the triangle A, B, C, B equal 30, C, A equal 50, then C 180 minus 50 plus 30 equals 100. It's clear that the smallest side here is AC. And this is the end of the lesson. I hope it was helpful for you. See you in the next video inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.